Good evening, everybody. Welcome to League of Extraordinary Inventors. I'm your host, Mike from Faraday Research. Welcome, everybody. It is Friday night. It's Free Energy Friday. It's the 21st of March, 2025. Welcome, everybody. Ben, Lulu, and Mr. Phillip. How's everybody doing tonight?
Good.
Good.
Good. Right on. Live stream is open,
How you
everybody.
doing?
We got all our usual people there. How's everybody doing tonight? It's been a busy week. I guess I have some stuff I want to present a little bit later. I know Philip is all ready and bushy tailed and ready to go on his stuff. So I guess we'll keep the same format and we'll let Philip take the stage.
Okay. 1 second. I'm gonna present the screen first and entire screen. Right on. So if I go here. All right, the little traditional cap here. So if I'm gonna start by talking about Salvatore Pais. Apparently, he works for the United States Space Force. The guy doesn't know what he's talking about. So I just want to clarify here. I'm happy for him that he's happy about his work, but I just want to clarify that when he talks about the super force is just C exponent 4 divided by the Newton's gravitational constant that gives 1.22 times 10 to the 44 joules per meter. And this is a theoretical value. This that represents the linear energy density that we are in, that the cosmos is in, that represents the vacuum energy, the 0 point energy, or call it whatever you want. It's all the same. And but the theoretical limit is way too high because it's higher than the black hole limits. You know, the black hole limits, which is 6 times 10 to the 43 joules per meter, which is, and how can a black hole be lesser than what we are in? Makes no sense. And if you calculate the Earth's gravitational field, just the energy of the gravitational field of the Earth is 2 times 10 to the 4 joules per meter. So there's an order of magnitude of 40 difference here, which is ridiculous. So that leads to the vacuum catastrophe. The Einstein's mathematics predicts that the dark energy density is very high. It's like even higher than what I'm talking about here, and what is measured is like completely the opposite. So the theoretical limit makes no sense, and Salvatore Pais keeps talking about that in his debates. He wants to debate. Well, why does I'm challenging him? Well, why doesn't he come to your show, Mike, and challenge me right here on your show? I'm not gonna go on his show. He's the one who should come here.
Yeah.
So
Well, I've never really put a shout out to him. I don't really have his contacts, so
yeah, no, but I know he's watching, but if he doesn't want to debate me, then he should go on cosmoquest.org and debate against all the anonymous physicists in the social public forum there.
yeah.
It's made for that. It's made to debate. So he should stop like making noise and just take some action here. Um, and so yeah, he doesn't know what he's talking about because the theoretical limit makes no sense. If we have that amount of energy, then I mean we should definitely harness. We should be capable to harness all the energy, but and the values the what I'm talking about when I talk about the force field, it affects directly the force field because um, like this week I bought the GPS though the with the oven cook oscillator, and I did try to measure the time dilation of a home electric current that is 120 volts and 15 amps. And I did try to hover the power cable next to the GPS door clock, and I didn't see anything. I didn't see any change. So it's not precise enough. Unfortunately, the I need the GPS door with the rubidium atomic clock. Is a lot more precise. But this one is goes around the tenth or the hundredth of parts per billion, which is the something around a millihertz, something like that. So if the precision is lower than a millihertz, then I'm not going to be able to measure the difference. It's not going to be precise enough, unfortunately. So I need to
Get more sensitive.
yeah, like I need to get the more sensitive one with the rubidium atomic clock. But I'm not going to do that right now. I just wanted to give a heads up here. If anybody else want to try this experiment, then um, this is this is important information I'm giving you right now. And yeah, and to go back to my calculations, um, here I'm having very nice calculations here. That one sec. See, I'm gonna show you. So this is the time dilation factor of a 15 amps, um, 15 amps home current. So if the linear energy density is very low, I think that's the correct value here. 1 times 10⁻³ um, coulombs per meter. Which, if it's very low, then it's the time dilation factor is gonna stay at zero here. It's gonna be very strong. You know, the time dilation effect is gonna be very strong, and it's gonna be effect. Sorry, not this one. Yeah, it's gonna be very strong, and it's gonna be effective for like 100,000 meters. You know, so if the linear energy density, then the time dilation factor will be effective for 100,000 meters, which makes no sense. But if it's extremely high, um, if it's extremely high, like 1,000, for example, joule coulombs per meter, then it's gonna be closer to one here. If I see the blue line on the top of the graph here. It's actually I'm gonna zoom in. So the time dilation factor will be less effective, which makes more sense. So, but if it's too high, if it's way too high, then the time dilation factor will be completely ineffective. So that's why. But the real value of that linear energy density, I'm not sure what it is yet, because that's what I wanted to measure with the GPS device. Unfortunately, it's not precise enough. Um, but I'm not sure about the required current to generate the force field I was talking about last week. I'm not sure what is the exact current that we need. Last week I said some number, but I got the calculation wrong. But now the theory, I got theoretical value, but it makes no sense. So it's something in between. The value is in between, and that's what I'm trying to narrow down right here. And also to talk about I did review the annihilation the annihilation of an electron and a positron. Earlier, I was telling you guys that the electric field was responsible to convert into kinetic energy, but that was wrong. I was wrong. I made my mistake. That's not what happened. I made the correction and I made the calculation this time to make sure that I was right. What actually happens when you have a charge 1 and charge 2, the x-axis is charge 1 and the y-axis is charge 2, and the z-axis is the resulting energy, the energy that comes out of the charges being close together, very close together, that for a distance of 1 centimeter. So when you have charges that are exactly have the same amplitude but the opposite sign, then they will create an outburst of energy. That's because of the time dilation here. It will create an outburst of negative energy, and that negative energy will convert into kinetic energy, and that's the kinetic energy that will give the speed of the photon, of the resulting photon. So not sure if you guys remember I don't have the annihilation picture anymore, but let me find it here. Annihilation. Yeah, not that. But, yeah, yeah. So no, not that one. It's more. This one here is good. Yeah, so that's a pair production, but the reverse of that is yeah, so this one here.
Yeah, that's the one you showed earlier.
Yeah, that was the one. So you have an electron and a positron. They clash. They merge together, and all of a sudden they gain that they convert into a photon, and they magically gain that c speed here, that light speed. But why?
Right.
Where's that coming from?
What?
Yeah.
Sorry to cut you off. So that would be charge acceleration, wouldn't it?
Yeah, that's exactly. That's when you get two charges of the same value but the opposite sign, you're gonna have an outburst of negative energy. You see the
Right.
vertical axis,
Hmm.
the Z value. You're gonna have
Right.
an outburst of
Negative energy.
negative energy, and
Now,
that's what
now,
gives the speed to the photon.
right now, give me. Uh, would this be fair to say that in regular physics, they don't even look at this, or do they?
No, no, no. No mainstream physics. They never. They think that C is a universal constant, but it's not a constant. It's the result of this graph here. It can be derived with this graph, this
Right.
equation on top actually.
It's a
This
pretty
equation
long.
right here.
It's a pretty long equation. But like my point is the fact that they don't even recognize this. They all they're looking at is the positive on the z-axis,
Yeah,
right?
yeah. Well,
That's their reality. That's the reality. A positive on the z-axis, not a negative on the z-axis.
yeah, exactly. So they don't even consider negative energy. But you were right. There is a negative energy.
Yeah. Oh yes, there is. Yeah.
Yeah, and uh, and I did the maths. I did the maths and the integrity check here. If I calculate the V here, the V equals to 2.99 blah, blah blah times 10 to the 8 meters per second, which is exactly the value of the speed of light. So when I do an integrity check, I get exactly the speed of light.
Right.
If I convert the resulting energy here, negative energy into speed, then I get the speed of light into kinetic energy. Sorry, if I convert this energy outburst into kinetic energy,
Right.
and I solve the speed, then I get the speed of light.
Now, um, I'm going to add something to this. So when you have a coil, right, an inductor, and you're pumping pulsed DC power into that inductor, when you shut the power off, you're getting a field collapse, and that field collapse goes to the middle of the coil, and that center point where everything collapses into in in magnetics, they call that the Bloch wall. Okay,
Yeah.
this is where the negative energy rebounds. Okay, because it can't go past the Bloch wall. When you got two of the same charge and they meet when they collapse at the Bloch wall in the middle, it can't go past that. Okay, so that is the result of what we call back EMF, because when those two charges collapse and hit the Bloch wall, right, they can only go this way, back out. So it's a rebound of negative energy in the positive Z axis. Okay.
Hmm.
That's what they call back EMF.
Oh,
That
It's,
okay.
makes
it,
so much sense. You
right.
know, like when it's explained like that, it makes so much sense. You know, like
Right.
it fits what
Because,
Phil's
like,
saying, what you're saying about, like,
thank you.
ah,
So when you get a magnet, right, with a magnetic field, the direct center of that magnet, that's the Bloch wall. That's where the positive and negative meet in a magnet.
Oh, okay.
Okay. So you have a separation. There's a center point of a magnet where when you cross the line, you're going from north to south. That's where the difference of the poles make, right? Same thing goes in a coil, okay? But the only difference is when you got two charges coming from the opposite ends of the coil, and the coil is polarized, it's a magnet. It's got the magnetic field going from the North Pole to the South Pole, exactly like a magnet. And when the field collapses to the Bloch wall, the center of that coil, it can't go past that. It has to go back out. That's why we call it a back EMF,
Oh, okay, okay.
right?
Yeah.
So that's basically where we get the extra energy from, is because when it hits the Bloch wall, you don't need any more power. the power is off. And when it hits that charge, when it collapses, it's got kinetic energy. It hits the blotch wall and goes, oh my God, I can't go any further. Boom,
Yeah.
comes flying back out. That's the power. That is where the over unity of a coil takes place.
Oh,
That
yeah.
rebound, the rebound coming back out.
No,
Is
I
it
see.
faster than light? The
Oh,
speed of that?
nanoseconds.
Okay,
yeah,
so it is
it's-
faster than light.
It's extremely fast and
Interesting.
extremely powerful. The bigger inductor you have, the bigger that rebound is. Now, what I also found out, the back EMF increases not on the length of the coil, it's the diameter of the coil. So say you got a 2-inch diameter and you got a 4-inch diameter coil. The 4-inch diameter coil will have a higher back EMF,
Oh, yeah.
right?
With higher amplitude.
Right. And because of that amplitude and the velocity of the field collapse makes the back EMF that much stronger,
That makes a lot of sense to me.
right?
A lot of the stuff you say goes over my head because it's like I'm not
Well-
as smart as you guys, but that
Well,
that
but
makes sense.
think about it. Think about it. When Tesla was making his coils, they weren't this big. They were this big,
Hey, yeah,
right?
yep. And
Makes sense.
his pancake coil was a spiral shape. You know,
Yep. Yep.
He-
Bigger
he
the
had a-
diameter,
Mhm.
the bigger the diameter, the larger the back EMF spike is. That's
Yeah.
why he was getting such an enormous amount of current coming back. That's why some of his Tesla coils were producing 2,500 amperes.
Wow. Yeah, that
Oh,
kind of
yeah.
aligns with some of my observations with the the rodent coil, the vortex coil, because it's basically a pancake coil in 3-dimensional toroidal shape.
Right.
Like it's a kind of in that way, it's kind of an extension of the pancake coil,
It's,
but
you know what? It's what you're doing is you're creating a magnetic field in a 3D geometry.
Yeah.
Okay.
yeah.
See, he's working on a linear plane. The rodent coil is in a 3D. So, in my personal opinion, the pancake coil is a lot more powerful than the rodent coil because of that fact.
With what he was doing with it, yes, I think you're right.
Yes,
because
by far.
but also I think they can both be used in tandem to do some amazing stuff outside of
Yeah.
what he was doing.
Well, you know what? Rodent coils, like for power generation, I'm still on the fence with the rodent coil. As far as creating fields, then yeah, then you're.
So I haven't actually even tapped the surface of what Daniel Nunez claimed about the coil. I mean, he claims that any true vortex coil has the ability of anti-gravitic properties, right? It has the ability
Sure.
to lift itself.
Sure, it does.
And I have no idea how that would work. But there's so many different properties to these coils.
Right.
But at the end of the day, the stuff that I'm doing with them is not disruptive to the energy grid or anything. Like we're just doing alternative, energy recycling, just try to get a little bit more efficiency out of your system.
Yeah.
It's nothing revolutionary in that sense.
Yeah.
That like what Tesla was doing
Personally,
with wireless energy.
this
but-
is my opinion, not to knock your work at all, but if you're looking for power gain, the rodent coil is not the way to go. Unfortunately, that's my opinion. Some other people might beg to differ, but that's just my opinion. And don't take it as criticism, please. That's not what I'm trying to do.
No, we got to work with what we see, and if I can't
Right.
get the kind of energy gains that I need to for a scooter, then I am going to pivot to a different, technology for that. You know what I mean?
Each coil configuration has a specific thing that it is
A purpose.
good for. A purpose.
Exactly. Right.
A
So if you want to
specific design.
Right. If you want to take like a single 12-volt battery, 20 amp hour to a camping trip and power your lighting, for like the entire week, 40 hours, this system is perfect for that, and you don't have to recharge the battery at all. So,
yeah. But, like I'm not discouraging you from working on the rodent coil at all.
No, we've had some.
It's great. It's, you know what? I think the rodent coil is very good for you for this reason and this reason. It's teaching you the fields and how they
Yes.
work.
No, you're exactly right. It's teaching me how the energy is working and flowing and how to work with it and not against it. And
Exactly.
and no, we've gotten some really interesting effects with the dual thief setup. And the wireless pickup method. And I think that might be actually the way to
Right.
go in maximizing the efficiency of the system. And
For
honestly, yeah, I've done a test, and we kind of partially closed the loop. We went.
Yeah.
I mean, if you want me to go into the details real quick, so the typical operating consumption for my single Lightning Thief device is 40 millivolts per hour on the battery. So
That's
every hour, yeah, it's nothing. But by making some adjustments, we managed to reduce that to 30 millivolts per hour. Recently, I thought I had, further reduced that consumption with the Paradox box, but it turns out that was a misreading. But we're now feeding the Dual Thief directly back into the battery. And when it comes to the energy consumed by the system, it's powering my 40-watt panel at 6.5% brightness and a 0.6 watt LED light bulb. But the only comparable devices I found were very small ones that accept that kind of low energy consumption, like low tech wristwatches we're talking about is the only thing comparable that'll accept that kind of energy and still run. So ChatGPT mentioned that finding a Dual Thief circuit that operates on just 30 millivolts per hour is extremely rare, if not impractical, as most setup circuits need at least 200 to 300 millivolts to start oscillating. I haven't found any devices that can run on such a small amount of energy.
What is your actual output on the Dual Thief? Have you actually recorded, voltage and current?
Yes. And we've gotten mixed results because we measured the DC and the AC, and they're different, obviously, but we're still picking up AC on the battery, which is weird.
Right. Okay, so what you want to do is on the output, of your setup, put it through a full wave bridge rectifier, put it through a very large capacitor, and then put it through another bridge rectifier again.
So you recommended that. We took out the capacitor in the middle, and just with the two full bridge, we got it up to 80 volts from 38.
There you go. Okay, so 80 volts. Now, what's your current?
So I wasn't able to actually measure a lot of current, and but I wasn't measuring it correctly. I need to measure it with a 1 ohm resistor, I believe.
Either a 1 ohm resistor, or you can buy a really good DC to DC watt hour meter. They use it for RC stuff. If you feed that in there, it can accept up to 50 volts. So you might have to scale it back or put a little bit of a resistor on your input for that watt hour meter. And that will give you an idea of the voltage, current, and it'll work out the watts in real time. Because
so when we measured, when we measured the single Lightning Thief output with a 1 ohm resistor, I got around like 84 milliamps. Okay. So it was registering, a little bit of current, but it was hard to nail it down exactly because,
See, that's the reason why you need the capacitor.
Yeah. Okay. No, you're absolutely right.
Like I said, put it through a full wave bridge, put it into a large capacitor, and then put it in another bridge rectifier again, and then take your reading off of that. The reason for it is this. When it goes into the capacitor and releases the energy flow is going to give you a more accurate reading of true watts out or amperage coming out of the system. Because, like, if you discharge a capacitor really fast, it could be 80 volts, but when you discharge it really fast, it could be as high as 100 amps, right?
Interesting.
But if you got a continuous flow going through that capacitor and then take your reading off that, it might give you a way better, more accurate amperage output. So that's the reason why I said bridge rectifier, capacitor, bridge rectifier. I said it for that reason. That reason is to get a proper voltage and amperage output reading.
And we're going to need that for the beta blocks presentation for
Right.
sure. And so that's what I'm going to be working on. Just so you know, like, so I'll probably be reaching out to you if I have any questions regarding that.
See, the other way you can look at it too, those spikes of 80 volts that are coming off it, they're transient. They're transient, right? So the capacitor takes it from being transient into true power.
Right. And you're changing the frequency, and I guess that's what converts the voltage into amperage, right?
Well, not even that. You're changing the energy density of the power coming in. So you got a high frequency, high voltage going into the cap. The cap absorbs it, absorbs that energy. So say it's 1200 microfarad. Now you got a charge density of 1200 microfarad inside the cap. Now the meter can take a proper reading of the flow. You see?
Before the capacitor or after the capacitor?
After the capacitor. After the capacitor. Yeah.
So going back to the actual like energy that it's using from the battery, like I haven't really found any other devices that are comparable that can, run this kind of lighting and, drain the battery so insignificantly. But I just wanted to update you guys because I did feed the dual thief output directly back into the battery just to see what would happen, and it wasn't like rectified or anything. It was just a pulse signal, and it did bring down the 40 millivolt per hour to 20 millivolts.
Right.
So it was pretty cool.
Yeah. The other thing is a fail safe too. When you do rectifier, capacitor, rectifier, you've changed the symmetry of that power. You'll have no problems feeding it right back into your source battery again.
Right, you can do it with a DC current instead of a pulse, like coming out of the exactly, and it'll probably be more stable. But I've been testing the pulse signal too, and it's interesting because I didn't think that it would be significant, and it did. It kind of like halved it. So I'm going to continue to tweak it and mess with the rectifiers and all that stuff, and I'm sure that we can maybe even close it entirely. I don't know.
Yeah. See, like when I did it, when I did it with the Renegade device, everybody's bugging me. Loop it. I was going, Loopy, just listen to loop it.
I know.
So I said, fine. So I came up with that method of looping it by changing the symmetry with the rectifier and the capacitor setup. I looped it back. Lo and behold, the current coming off the battery that's running the thing went down. My motor speeds up.
Interesting.
See what happened?
Huh.
Is it draining the battery faster?
No, it's draining it less.
Yeah, it's taking less strain on the battery, so it's able to freely spin faster. Is that what's happening?
Well, no, it's adding the power to the circuit and just feeding. It's recycling the power coming back in. Instead of going into the battery, instead of going directly in the battery, what a certain percentage of it is, but most of it gets recycled and just bypasses the battery and goes right back into the circuit again.
Nice.
So the motor speeds up, the current demand off the battery goes down.
That's cool.
I've done this several.
Okay.
Right.
I just wanted to end with my theory of why my vortex coil kind of like operates the way it does. And I guess my ongoing theory is that at this time, the vortex geometry of the coil combined with the 180 degrees phase shift between the two channels, it's establishing a 0 point on the equatorial plane between the two counter-rotating fields. And since this 0 point is a null zone, it throws out radiant energy. And this could explain why we're seeing more back EMF than traditional systems. And I think Malcolm came on my stream the other day and kind of like, verified some of my lecture about that. So that made me a little more confident in my theory.
Do you have an RF meter or Tesla magnetic field meter?
No, that's something that I need to get. It's on my list.
Yeah, get one because like I do some tests on some of my devices, and I was standing about 2-3 feet away from my device and still getting readings. So
yeah, I do have an electric and a magnetic field meter.
So Yeah.
I'll
I
have to get
them.
with you, Phil.
Yeah, it's only
Yeah.
it's a small meter. It's only about this big. And you
Yeah.
just hold it and the light will start beeping when it detects a field. It'll tell you how many Tesla is picking up, right? And it's a Gauss meter. Thanks, Mike. Um, Electronic Gauss meter. So you can see how far that field is emanating away from the rodent coil. The biggest field I ever produced was 4.5 feet away. I was
That's pretty
actually
big.
quite surprised. Yeah.
Yeah.
I was pretty
I
surprised.
took one time one of those meters and I went up on a mountain where there's those huge receivers and I wanted to see that thing. My God, that thing was like it was
going off like
bringing,
crazy.
yeah, like I almost even dropped it. Like the thing was like it was going like that, you know. It was getting like those really strong readings. So yeah, they're nifty gadgets.
It's dirty RF, right? It's just emitting
So the dead end channel said on my chat, the AC on the battery means the battery plates are ringing, and that makes sense. You know, you're picking up an AC signal right off of the battery terminal.
But
that's not common, but it makes sense if you're, in full resonance.
If you're, see, the thing is too, a lot of people don't realize, when you're working with the lead acid battery, right? You're getting a reaction of the battery chemistry inside. So what will actually happen if you get the right frequency going, you'll have several effects happen like Bendini was doing. Desulfation of your plates inside the battery, right? That will actually start to happen. Number two, the chemistry, the lead acid, you'll actually get it bubbling. You'll actually start to boil inside.
You think it's like cavitating maybe?
Yeah, it's creating a cavitation inside the lead acid battery. So depending on the battery you're using, gives you different effects of that, that power that's coming back into the battery, right?
Right. So, yeah, we just tried I did a quick test the other day just to see if it would charge, pulse charge any low tech equipment, and it did. The system, I unplugged it from the lights and it was charging my oscilloscope, my small handheld one, pretty fast for a pulse charge actually. So it was pretty cool to see that.
Yep. Yeah.
And I guess I heard that pulse charges are a little bit healthier for lithium, or can be if done correctly. Is that?
You have to be careful with the lithium. Lithium gets very unstable. They have to be pulse charged properly. That's why you get the problems with the lithium runaway, right? You get the overheating of the lithium. It has to do with the lithium itself. It heats up.
So is there a specific range that I should stay in, or regarding frequency?
I don't really dabble too much with lithium. Like I'll play with the lithium iron phosphate battery, but not a pure lithium battery.
Well, hopefully the oscilloscope doesn't blow up. It seems to be stable.
Yeah. Well, if it's not heating up, you're okay. Just monitor the heat.
Okay. Yeah. No, that makes sense. I'll keep the eye on the heat.
Heat in a battery is not good for any battery. That means
it seemed to be staying cool. So yeah, it seemed to be actually charging pretty healthily for a pulse signal.
John Smith did a very cool idea when he was looping his system back because of the high frequency he was using. What he did was he got two diodes, positive and the negative. He would flip them. So one diode is on the negative side of the positive. He just flipped them like this and put that wire going back to the battery. What happens is, in theory, the light shouldn't light up. Only one light should light up. But if you got it right and it's charging properly, both lights are on.
Wow. And I already have one of the high-speed diodes on the positive when I fed it back, but I don't have one on the negative. I'll try that.
Yeah. So if you got that right power coming back to your battery, do that trick with the two diodes flipped, positive to negative on both sides, hook it up. If both LED lights go on, that means you got the right type of frequency of that power coming back. So that means it's going in both directions.
Hmm.
Power coming out, power going in. You got a two-way street.
Yeah. Yeah, and with the back EMF, you want to keep an eye on the negative as well. The negative line.
Yeah, exactly. So
Yeah, no, I've
that's
been
the-
taking. I was just
Yeah.
sorry. I'm sorry, I didn't mean to interrupt.
Go ahead.
I was just gonna say, like, I've been taking current measurements on the negative. Is that something that you would recommend as well?
Sorry, say that again.
I was taking current measurements from the negative line as well as the positive. Like, is that something that you would do as well or recommend, or does it really not matter?
I do it myself just to see what's happening on the negative, because like especially in the Don Smith stuff, you have to have earth ground, and that's where you can really pull a lot of power into the circuit. And that was another reason why Don Smith did that trick with the LEDs. He flipped them. Right?
Yeah, I know. Michelle has got two earth grounds. He got certs for them to put them in his backyard or whatever, so he can use them. So he's got utilizing two grounds. So I'd like to do that, and see what kind of power we can pull.
Yeah. Okay, I got a couple things I want to present here.
Sure.
The pyramids of Giza. There was a huge discovery made in the last week. They had two guys go in with a special radar system, and I'm just going to show you and see if you guys can figure out what they found.
A gravity well?
Okay, this is under the pyramid. All right, I'm going to put it full screen here. All right. They found a structure 2 kilometers deep below the pyramid. A shaft, a hollow shaft below the pyramid. This is the second largest of the 3 pyramids at Giza. So let's go here. Okay, can you guys see this?
Yeah.
Okay, I'm going to play this video here.
You there?
Hold on a second, guys. Something went wrong here.
It's ugly.
Just going to back up here. Try my screen share again.
Green coach.
All right. Can you guys see it? The pyramid?
Yeah.
Yeah. Yes.
Okay.
Corrado Malanga from the University of Pisa and Filippo Biondi, involved in radar and remote sensing research with the University of Strathclyde, published peer-reviewed research in 2022 via MDPI entitled Synthetic Aperture Radar Doppler Tomography Reveals Details of Undiscovered High-Resolution Internal Structure of the Great Pyramid of Giza. Their research was conducted using SAR data, synthetic aperture radar, along with proprietary software developed by Filippo Biondi that transforms the radar signals into phononic information, which allows for the detection of millimetric vibrations. This cutting-edge technology is capable of revealing underground structures invisible to traditional methods and revealed internal structures never seen before. Having established their expertise in using SAR to explore pyramid structures non-invasively, a recent press release on their current project was released last Saturday. This March 15th press release summarized the key findings in the team's research of the second largest pyramid of the Giza Plateau, known as the Khafre Pyramid. And what they found was astonishing. The analysis of dozens of tomographic SAR images obtained from different angles enabled the 3D reconstruction of inside the pyramid of Khafre and deep beneath the surface of the plateau. Near the base of the pyramid, 5 identical structures are seen, connected by geometric pathways. Inside each of these are 5 horizontal levels and a sloping roof. Below these 5 structures are 8 cylindrical structures, which appear to be vertical wells, hollow inside, and surrounded by descending spiral pathways. These 8 vertically aligned cylindrical structures, arranged in 2 parallel rows from north to south, descend to a depth of 648 meters, where they all merge into 2 large cubic structures, measuring approximately 80 meters per side. The entire structure extends approximately 2 kilometers beneath the surface and extends beneath all 3 pyramids of the Giza Plateau complex. Mainstream Egyptology tells us that the Giza pyramids were tombs for pharaohs Khufu, Khafre, and Menkaure, and that they were built around 2500 BC using ramps, sledges, and levers. But the redundant mathematics in their construction, which include pi, the golden ratio, and the speed of light, along with the testimony of today's expert architects, suggests that the official story does not hold up. The massive underground structure revealed by the recent SAR data shows what appears to be a mechanical or functional system, and this has been hypothesized in the past. Nikola Tesla believed that the pyramids could harness Earth's natural frequencies. This arguably inspired his experiments in wireless energy transmission and scalar waves. In the Giza power plant, Christopher Dunn argued that the Great Pyramid was a power-generating machine using resonant and acoustic forces to convert mechanical stress into electricity. In the Giza Death Star, Joseph Farrell proposed that the Great Pyramid of Giza was a weapon of mass destruction using a type of physics that he calls paleophysics to focus energy as a scalar weapon. The cylindrical wells could be conduits for energy or sound waves, and the cubic structures might serve as energy storage or stabilization units, akin to components in a large-scale weapon or generator. And the detection of vibrations in the pyramid's internal structures reflects all of these ideas. The Khafre project hopes to plan an excavation in order to discover more about this underground structure, but history shows that this will be very difficult to get approval for. Greg Reese reporting.
Oh, why is everybody not there?
Wow,
you hear
we're
me?
here. We're just like, wow, it's really like,
This is
Yeah, it was mind blowing.
yeah.
I don't know
this is
why.
huge.
Can you guys hold on
It's
here?
on here.
I don't know why we're not up on this thing.
Angela.
It's okay. From a moment, everybody.
I don't know what's going on here.
When?
Why is this going on? Why is nobody on the screen?
It's working.
Okay.
There
Okay.
we go.
I don't. Oh, hold on. Duh. Okay, I got it. I know. What am I doing? I don't know what I'm doing. I'm just eating puffs. So, what do you think of that? That's pretty wild, eh?
Yeah.
That's big. That's huge.
That's huge.
yeah.
2 kilometers down.
I wonder what the spiral staircase is made out of.
I think it's a coil system. I think
Yeah,
it's an inductor.
yeah, but I
It
would
might
like.
not be a staircase.
Yeah, is it metal? Is it copper? Is it
Maybe,
gold?
maybe there was liquid mercury that went through there.
I don't know.
Wow.
But that.
What do you think, Phil?
Yeah, I mean that's. I didn't know. I know what I'm gonna look at tomorrow after my training. I'm gonna do. I'm gonna look at that deeper. It's very interesting. Um, I don't know what to say because I don't know.
I think that's a huge discovery. You know, they prove that there is definitely something below the pyramids. And they're
Yeah, 2 kilometers like below.
1.5 miles.
Yeah, but
Like all
miles
those things,
down.
like, is it an opening to the hollow earth? You know,
No,
down there. Is
it's
it? You know,
what you're looking at is an ancient Wardenclyffe Tower.
Yeah, grounding system.
Tesla. How do you think Tesla's system works? He took it from the pyramids.
Yeah, somehow he knew that they were grounding it that way.
well, it's like Nathan's device that connects, gets the energy from the mud.
Yeah, exactly.
Tesla, when he made Wardenclyffe, right? Most of his devices he set up near huge bodies of water. So Wardenclyffe, and I think it's on Long Island, if I'm not mistaken. His ground system, not only that it went far down, it also he had a huge bus bar going out into the ocean. What a better ground system than the ocean.
But
So
so how long did you say it was? Like 2 kilometers or something? That's crazy.
that's
But
huge.
that's at that level. If you're in the desert, you're gonna hit water sources that deep. You know.
I don't care what anybody says, that is not a human made structure. It is impossible for humans to have constructed something like that.
Yeah.
That
alien.
is extra alien, it's extraterrestrial with technology way far beyond what we couldn't do that today.
Yeah.
Right?
Yeah.
2 kilometers is really like that's deep. Like really.
1.5 miles.
Yeah, there's a
1.5
reason
miles.
why nobody's replicated the Great Pyramid, because we can't do it today, like you said.
You can't do
Let
it.
alone all the
I
let
mean,
alone the two
listen,
kilometers.
it is doable. It is doable, but you have to have a tyrant, and we all have to be slaves. Nobody gets paid. Nobody they just work. It can be done, but modern day, like
It's true, Lulu.
Yeah.
Yeah, that's true. That's true.
I'm just
Touche.
gonna scoot out for a quick smoke. You guys just carry on.
No, it's just a joke. Don't. It's just a joke. I don't want to get political,
No.
but can you imagine if the Ukrainian are losing the war against the Russian and become their slaves?
Oh,
Then
fuck.
I don't want to. No, I love Ukrainians, but they just. But if you go back 2,000 years ago, or 4,000 years ago, that's how it was. You go to war against somebody, you lose
Yep.
it, and you become their slaves.
You're exactly right. And we need to heed history's warnings and pay attention to those patterns if they happen,
Yeah.
I think now we're much more integrated to where others would kind of object to that. Back then
Yeah.
there was no media, there was no televised things, there was no so.
That's true. There might be more of a backlash, and they got to be more political and more what's the word?
We might put tariffs if they don't, become civilized. We might,
right. Diplomatic. That's the word I was looking for. Diplomatic.
But yeah, that's really amazing. I like it for that time. I think Mike is right. Like there has to be some extraterrestrial aid to build something like that. Like
I will not rule it out.
you just
You see what it says right here? I want to believe.
I already believe. I don't. It's not. I want to believe. I already believe. I'm 100% believer in that. So
I think I know why people before were always at war. It's because their food was so bad, that they got frustrated very easily. They were eating something, some chicken, some raw chicken, and it's just, damn,
Our
that's
food's
bad.
bad. Let's invade the French to get all their good food.
Yeah, something like
man.
that.
that's probably not too far from the truth. Like yeah, food is the motivator.
Yeah, we're laughing, but Lulu, you're probably right.
Motivator.
Yeah, it is. It's a big motivator. It's a big motivator of mine.
That's even in modern days. It's a motivator.
Yeah, bribe me with money, but maybe a ham sandwich? No.
So don't give Ben a bologna sandwich or he's gonna get mad.
I might get flatulent.
Good food. Yeah. I mean, think about it. If somebody invites you to like something, not so cool, be like, you know what? It's a long drive. Nah, it's all right. I don't want to. I don't feel like it. But if it's really good food, you're probably willing to like drive 2 hours just to eat something good. So yeah.
Oh yeah. If I got money for the Cheesecake Factory, you best believe I'm driving 2 hours.
Are there cheesecake factories in Minnesota?
Oh, you mean in Michigan?
Michigan, yeah.
Yeah. We got a couple.
Yeah,
Oh, they're so good.
yeah.
Their cheesecake is good. Yeah.
Mm-hmm. They got such good food and amazing desserts. Yeah, but it's just a little expensive. But every time I can, celebrate with Cheesecake Factory, it's a good place to, make a reservation for a date.
Yeah, so it's the same principle. She's not gonna get mad at you if you cool her off with some good quality food.
Proper cheesecake is the key.
Hey, Crypto, he's joining in 15 minutes. Awesome. Good to have you here, brother.
Yeah, make some noise, Bernie. You missed my part. Unfortunately, I did my challenge, so let's rewind it if you want to hear it. Against Salvatore Pais.
He laid down the smackdown.
I'm gonna do the X Factor.
Snap into that Slim Jim, man. Oh yeah.
Oh man.
So the negative energy gets added on to the total sum, because energy is energy, whether it's positive or negative, it's still energy.
Yeah, exactly. So negative energy is just gonna go in the other direction. That's about it,
But if you add the total sum, it would be both. But mainstream just uses the positive and never adds in the negative. So you're really like it's missing part of the total value of energy.
Yeah, exactly.
You're absolutely right.
They can't derive the speed of light, so they say that it's a universal constant. I just derived it. It's not a universal constant. It's the result of the equations that I just gave, and I checked the integrity, and it works. I get the exact speed of light that I was looking for. So
So when
It
you were saying
worked.
10 to the power of 44, you said that that's like an impossible unit, it's
Yeah, joules per meter.
okay. So where does it where is it still measurable? 10 to the power of 23 or 33? Like where
Uh,
do we say is it like
for
it's
40,
still
43 is the black hole. Here,
okay?
I'll show the image again. It's very. I don't know if I can share it because Mike
Hey,
is not here.
I caught you guys going off the rails without me. How dare you?
Yeah. Can you share? Can you mind sharing my screen again?
Yeah, I got it.
Yeah.
So,
So the Planck constant is 10 to the 44 joules per meter.
Okay.
The black hole is 10 to the 43 joules per meter. Neutron star is 10 to the 33 joules per meter. So you're not going to tell me that the Salvatore Pai's super force is stronger than a neutron star, it's or a
Well,
black hole.
if you listen to Tesla, Tesla described light as waves that, propagating through the medium, the aether. And, any the speed of anything is determined by the density of the medium it's going through, right?
Yeah,
So
yeah, exactly. So
makes sense.
that's why there's variable speed of light. The first Einstein paper that he released on light bending was based on variable speed of light, and that's exactly what finite theory is based on, variable speed of light, because it's proportional to the energy density. So the denser the environment is, the slower the light will travel at.
So when there's like a like those nebulas, the gases, the light travels slower. So
Yeah.
for us, it would show sometime. Does the color have anything to do with the speed of light? Is that why we see them more on the reddish side versus, or that is a different thing?
Um, that's an excellent question, Lulu, because the speed of light is the light is refracted when it goes through a medium,
Mm-hmm.
and the higher the frequency of the speed of the light is, the less it's gonna bend. So the lower the frequency is, the more it's gonna bend, because it travels slower. It actually is this speed of red light is slower than the blue light. Not by a measurable factor here, but if you get the distance, if we talk about the distance of the supernova that exploded away a billion years ago, then you will measure difference between the different colors of the light. And I think I talked about that before. It's written in my paper. Um, so for a supernova that exploded like trillions of light years ago, the we get different colors at different times. So there's a delta time, a delta seconds between the colors, which proves that the speed of light is different based on its color, and it plays a role with the refraction. If light goes through a medium or a prism, then it's gonna deflect differently based on depending on its color, because the
Mm-hmm.
speed is gonna be different. So yeah, I'll try to do a cleaner presentation at some point, because what I'm talking about is a little bit scattered, and I'll do a cleaner presentation at some point with all this
But
this
it still answers
information.
my question. Like the color has determinant on distance and density of whatever particles are, in
Yeah,
this.
yeah. So um, the speed of light is going to be different. Is gonna deflect differently. for a specific medium. When it travels through a specific medium, it's going to deflect differently because the speed is going to be different.
Yeah.
So when they say the speed of light is constant, it's not constant. It's variable based on its color. You have variable speed of light, and you can derive the speed of light. I just proved that you can derive the speed of light tonight on this March 21st, 2025. It's historical, man. Your show is historical again, Mike.
I'm historical.
Yeah. Just don't get shadow banned, not to get your shows.
I've been shadow banned again. Like I'm stuck on like 32 or 3,300 subscribers, and it, we were getting good numbers for like viewership and everything. All my numbers are up, but my subscribers have just like stayed there. They're not doing anything. It's discouraging.
Yeah, I've heard a lot of people like complain. Like some people, like it just stands still for, like months. Before they see something.
Yeah, I'm at 3,370 subscribers. I've been stagnant there for the last 3.5 months.
So what if we do a little experiment and get all your subscribers, whoever watches, to put their name? Then you can collect the names, call YouTube, and if there's any discrepancies, more than that, you say, why are you jipping me with my subscribers here? I've got legit names that, Yeah.
Mike, what you should do is take these League of Extraordinary Inventors podcasts and cut them up with a website called Submagic, and it'll add like all these animations and subtitles in really catchy ways automatically and clip like the best moments. Okay, and then you just upload. Yeah, Submagic. Yeah.
Are you talking about black magic with Ouija boards, Ben?
No, nothing like that. Just a little tech magic.
All right, I got it there.
Yeah, and it'll automatically clip like the best like viral moments. It catches with the algorithm and translate everything with subtitles and animations. It's really cool.
Okay, I'll check that out.
And try to upload at least 2 to 3 if you can per day, because it'll split them up into quite a bit. So spread it out.
Right. So you would upload a whole video or just a small portion?
So it would be like a short. It would turn them into shorts. So nothing more than 3 minutes, and then you would upload, 2 to 3 shorts per day, schedule them. And then, you have them scheduled for the whole week, pretty much off of that one podcast you did.
Yeah.
And it'll just keep the algorithm saying, hey, there's more stuff being uploaded, let's share more.
Right. Cool.
That's what I've noticed the difference. Yeah, no, it was a tip from Nathan actually, and it's really boosted my numbers.
Yeah. No, like I got good, like all my numbers and like viewership and how long they're logging in for and my click-through rate, everything's like really good, like better than I thought. But my subscribers are like stagnant. They're not going anywhere.
Yeah, and I had the same problem, and it's honestly the algorithm changed. If you don't upload anything, videos or shorts, it like dead channels that don't have anything, they don't share any of the old videos anymore.
Right. All right. I guess I'll have to come up with a plan.
Plan B. Plan B. Mike's plan B.
Plan B. You don't want to see my plan B.
Well, I try to promote, you as much as I can on my channel, and sometimes I'll, funnel some of my viewers to your guys' channels as well. So, that networking helps too, the grassroots movement.
And my plan C, you definitely don't want to see.
Does it involve the renegade?
Why do I feel scared now?
Oh man. You don't want me to pull it out. Sorry. This is a family show here.
Some sort of super coil gun or something like that.
Yeah.
So
I
have
don't
you
know.
guys
After 10
heard
o'clock, it turns into Adult Swim.
See me put the CN Tower into an oscillation.
So
Yeah,
have you
go
guys
for
heard
it.
about them finding a new lithium repository north of Nevada, and it's going to
Oh,
substitute?
they're all over. Oh
Uh,
yeah, thanks for reminding me about that.
yeah.
I've been checking around Ontario. Apparently, it's about a 3-hour drive from me. The county, get this, it's in an area called Bancroft, which is about 3 hours north of Toronto. Okay, and I was doing a search, and I don't know, I typed in Faraday County. There's a Faraday County in Bancroft. I was like, it's
Did Nick
named Faraday.
go there?
Faraday.
Or
Yeah,
no,
it's an
Faraday.
actual.
Why am I
Yeah,
saying
it's
Faraday?
actually a place in Bancroft, Ontario. It's called Faraday County.
Hmm.
So I was digging deeper, and it turns out they got a bunch of mines up there that they were using back in the 1940s, 1950s time frame, and they've been mining uranium, thorium, a whole bunch of like nuclear materials are coming out of this place. And it's only about 3 hours from where I live.
Well, now
So
you know if you need any of that stuff, where to go. You know,
Bancroft, Faraday County. But it was so cool. It was named Faraday County. I'm like, yeah,
it matches the show. Perfect.
I gotta move there.
Yeah,
So-
but like they're gonna stop importing from Brazil, Argentina.
We
like,
have it all here. We have it all here. Canada is so rich in iron ore and all the nuclear isotopes, thorium. We got lithium here too in Ontario. I didn't know. So it's everywhere. You just, yeah. We have such a huge landscape here in Canada, right? We have all the materials, lithium, all the stuff.
All the raw resources that you would
mica.
need.
like
Yeah,
usually
like,
where
it's a
the
huge
terrain
list.
mountainous, like you're gonna find all that stuff. That's what
Gold.
based
There's
on
gold
Mm.
everywhere. Yeah.
topography.
Yeah, a lot of people don't realize we get like 50% of our energy in America from Canada.
Yeah.
I didn't know.
that much?
Uranium.
Yeah.
Yeah, the uranium. Yeah. It all comes from Canada. We have the largest deposit of uranium in the world.
Wow, I did not know the United States. Like, it's
The States has it too, but not as much as we do. We have, our square kilometers or square miles of land we're quite a bit larger than the US, like size.
And your guys' power grid infrastructure is a lot better than ours too.
Yeah, we have a very good power grid here. That's why we feed Michigan, New York, Minnesota. It all comes from Ontario, all the power.
I just got word from my construction boys that the Gordie Howe International Bridge to Canada the project should be finishing up within the next 3 to 4 months.
Oh, really?
Mm-hmm.
Cool.
I know Quebec is feeding New York a lot also. They
Yeah,
have a lot of rivers here and a lot of water.
Hydro, all the hydro
hydro,
plants
yeah.
up in Quebec.
Mm.
Yeah.
Yeah, dams are one example of over unity. Like they
It's
output a
free.
lot more.
That's what free energy is. Hydro, it's free energy. It's
The water.
always flowing. It's always going. You don't have
Yep,
to put
and that's
any
an
energy into it. It's so if anybody says free energy doesn't exist, well, you got solar, you got hydro.
Yeah.
You have all these
It's an
different sources.
examples of open systems.
Yeah, because it's
the hydra, the water wheels, right? This is
Yeah.
what we're talking about. Water wheels, really.
mhm.
In a way, these existed 200-300 years ago in some parts of the world.
probably longer.
Yeah, they did know how to harness something back then. Before we even really knew what electricity was. I've seen these for in real life, like these big water wheels that are like 300-400 years old and still working. That's the funny
Yeah.
thing. Yeah.
And they can power a lot, they can be used
Oh, yeah.
for not just electricity, but to power gears and stuff,
Yep. Well, back in the, I guess it'd be around the Dark Ages, they were using, windmills, and they have these giant slabs of stone,
Mm-hmm.
and it would be on a wheel, and it's powered by the windmill, and it goes around in a circular motion around an axis point, and they would put grain in there and use this giant wheel to crush all the grain.
Huh.
Wow, that's
Yeah.
cool.
Interesting.
So they used it for food processing. So, yeah.
I've seen something like that, but I think I've only seen the bottom portion, but not the top cap where you put the grains. And they were talking about it like I think like this is, I'm hearing for the first time that it was used. But when you're talking about what you're talking about, I've seen only the half portion, and they were speculating on what it could have been used for, so. Yeah, the big stones, makes sense. Like
grinding stones. Yep, break down the foods, grains, wheat, all that stuff to make bread. They were using all this back in the Dark Ages. So power of wind. Well, the only problem with the power of the wind is the wind's not there. You have no power. Where hydro, or using a river, the power of the river to run a wheel, that's always going to flow. That's free energy right there.
You're using the perpetual
Niagara
motion of the
Falls.
earth or whatever.
Yeah, it is a perpetual motion. There'll be a lot. Niagara Falls can be flowing way after I'm gone. You know what I mean?
Yeah, I don't like that word because it's attached with negative connotations in the scientific realm. You say perpetual motion and everybody just, they throw you in the crazy bin.
Yeah, it's the stupid religion of science today is so off. They just cannot face the fact that perpetual motion does exist.
It's frustrating, Mike. It really is. And you probably experienced this where you actually have something that challenges those conventional thinking, those conventional thoughts, and nobody just gives you the time of day because they don't even want to look at it.
They just flip their nose up, and it's just
you just explained the epic chat right there.
Oh man.
Nobody wants to argue there.
They just don't want to accept it. They just don't want to accept the fact that free energy is real and perpetual motion exists. Our universe is a working organism that's been working for well over 13 billion years.
Yeah.
Right?
And the best technology comes
motion.
from nature. The best technology comes from taking what nature does and utilizing it,
And that's what Tesla says. The wheel works of nature. Right?
Yeah.
You're going to mimic or tap into the wheel works of nature. He said that for a reason. He didn't say it for just because it sounded good. You know what I mean? Right? Yeah, we laugh about it, but it's absolutely 100% true.
Yeah.
That's how retarded it sounds. You know what I mean?
Yeah. Yeah, one of the only audio recordings we have of Tesla is him talking about tapping into the cosmic energy. I implore people to go on YouTube and look that up. It's really interesting.
So that's why I've been really focused on the material sciences, making graphene and making all this stuff, because that's going to be the key to capturing this energy that we know is there, just don't know how to capture it, right?
Yeah.
So until we figure out how to capture this energy, like even the Casimir effect, just having the two plates close together, and then the Casimir forces just push those plates together, which means there's a force on the outside that's pushing those plates together, right?
And these are very simple concepts too to wrap your head around. They're not very complex when you actually understand. Like, we're just seeing fractals of nature, and there's nothing really new here. There's the what's going on in the macro is really what's going on in the micro scale, and to understand that, it kind of simplifies things. And
So, like, say, like gravity, like I have my theory on what gravity is, and a lot of people don't think that far out because they think gravity only exists on a large body. I think that's false. Gravity also exists in space, but the fact is, when you're on a large body, we can feel it, we can detect it, it's there. But the same gravitational forces still exist in outer space. The reason for it is this, and this is kind of based on my quote unquote theory of gravity. The Earth is spinning at about 500,000 miles per second through space in our orbit around the sun. It takes 1 year. Okay. Our whole universe is also in motion, going thousands of miles per second through the void of space. There is motion there. So if there's a little tiny, say, a graviton exists, okay, I kind of believe that. But if you want to get down to the Planck scale, those particles are hitting your body while we're in relative motion, spinning around the sun, as well as the universe going through the void of space at a ridiculous speed. Those tiny little particles that we call muons and quarks and all those are bombarding our body. But in outer space, we can't detect it until we get onto a large body. And we feel those forces because we're drawn to the closest relative ground constant.
That's interesting. So what you're saying is gravity is everywhere. It's just we can detect it on large bodies, kind of analogous to like a wire producing electromagnetic field. But when you spin that in a coil, that's more detectable.
Yeah, it's because we're on a large body, we can feel it. Or because when you get to, I think it's 90 miles from the ground, gravity starts to disappear because our influence of our relative position close to the large body is getting further and further away. So the effects of what we call gravity get less and less as we go higher and higher. Okay. But even in outer space, we're still traveling at thousands of kilometers per hour through space. Right? So here's an idea. Eric Dollard actually made a good analogy of it. Like this bottle of Pepsi here has a lot of potential energy in it. He says if we're traveling through space at 500,000 miles per second around the sun, and we decide to throw this Pepsi off the train, it'll make an explosion probably big enough to wipe out the whole city of Toronto. That's how much power, how much kinetic energy is in this bottle of Coke. We don't think of it because we're on the planet. We're fixed. We're in an arbitrary constant of zero. We think we're at zero, but we're not.
Yeah, that's exactly why the Michelson-Morley didn't work. That's because Michelson-Morley was expecting an absolute ether, but the ether is relative. The ether is relative to the Earth and the sun and so on. So they're all superimposed gravity layers,
right,
that adds on top of each other.
Yeah, I know. There was the experiment was rerun on a different axis, and you're saying that could change depending on maybe like the time of year or something.
Well, I mean, if you do the Michelson-Morley experiment aboard the International Space Station, you will get different results, and that's what I've been suggesting for the last 10 years with the mainstream physicists, and they just try to bury me and shut me off and things like that.
Yeah,
they all know it's not gonna work.
I know how frustrating that is, Phil. So
see, like like Dollard was saying about, this theory of, having this bottle of Pepsi have so much power in it, it could wipe out a whole city. Is if we were able to throw it off the train to zero, where a stop, like a ground point. But we don't have that because we're running in relative motion, right? It's like perfect example of it is this. You get in a car and you accelerate really fast and you get thrown back in the seat. And then when your inertia wears out, goes to zero, you're not glued to your seat anymore, but you're traveling at 100 kilometers an hour.
Yeah.
You see what I'm saying?
Yeah.
Because
you don't accelerate, you have a constant speed.
Right. So what's happened is now when you slam on the brakes, the car's slowing down because you're applying friction to that motion that you're going in that direction.
So you decelerate.
But as you decelerate, but guess what? Now your body is still going the same speed. So that's why you go forward.
Exactly.
When you slam on the brakes.
Yeah.
Because your body is not being braked. Your inertia of your body continues to go forward.
Exactly.
Right?
Yeah.
Just an idea.
On that note, I have a question. If things all have like a gravity ratio, shouldn't elements in the atmosphere be like for example, the higher you go, less oxygen, because oxygen is a heavier element, but the lighter elements, if theoretically, if we were to go right before the ozone layer, shouldn't we be able like to find hydrogen, helium, like the whole ladder, because of just the atomic mass? It's lighter, it's going to float up.
Well,
right?
all those elements are in space. They all exist.
And the moon, and in like heavier isotopes, and like in heavier compounds as well. It's very great thought, Lulu.
What's going on, Bernie?
Just
hello,
make
hello.
sense. Hi, Bernie.
Hey Bernie, I know you're smart. What's the actual linear energy density on the surface of the Earth? I'm trying to figure that out.
Oh dear, linear density on compared to what? Like
just on in terms of joules per meter, because I did try to explain.
So when you go below in the ocean, you get exponential increase with the differential, and when you go up, you also get exponential increase from the differential into atmosphere, and then you connect the two, and then you get real power right there. So it's like on ground level, I think it's zero, but when you connect into the ground and you connect into the atmosphere, then it goes up a whole lot more, right?
Yeah. Well, it's some sort of energy density, but it's actually what Salvatore Pais keeps talking about is super force. I keep trying to explain that how because he's using a theoretical limit, and the limit is nonsense. It's greater than a black hole, so it's nonsense. And but I'm trying to get the real value because it's gonna define the real value is gonna define the strength of my force field that I'm trying to come up with. And that's why it's very important. If it's too low, if the value is too low, my force field is going to be very strong. But if it's too high, my force field is going to be very ineffective.
Well, so then to adjust it, you would put some energy up, like an antenna up or an anchor down over ocean or into the atmosphere to ease or increase, right?
Well, I'm going to increase the strength with the current, like an electric current. The linear energy density is just an ambient value that I'm not sure of, and but to for the strength, I just need to increase the current of the
I know of a few papers that like show it because it's like it differs on from sea level how higher up you go, right? Like it depends on the height of the land of where you are, is one thing that affects it majorly, right?
Okay. Yeah, there's a lot of factors. There's the gravity, the gravitational potential, the electric field, the magnetic field of the Earth, the cosmic energy, the solar energy, then the solar flux. So a lot of things. So, but um, that's why I just wanted to know your opinion because it's a very important value. With that value, it's gonna define the strength of the
Yeah,
force field.
I'll look up afterwards for you and I'll get it ready for like an email you or something, the papers that I've read on it for before that are a little older that were like measuring it and like calculating different aspects of it.
Oh,
They did
cool. Thanks.
they did a lot of it in like the 1800s to like early 1900s. It's in a lot of the science books from back then.
Okay, but I guess it's uh, yeah. If it's too theoretical, I'm afraid it's going to be offset. But if it's measured,
No, it's all measured stuff. Like they literally measure the differential from the ground up
oh,
into the
okay.
atmosphere and like give you different equations on how to actually calculate it and stuff.
Oh, cool. Awesome. All right. Thanks.
No problem, my friend.
So I did some work on my Earth batteries. I got 5 cells going now, and I'm running a
Very nice.
capacitor bank with a chaser light on it. So these are putting out about 9 volts.
Oh, cool.
Yeah,
That's really cool. 9 volts, and
and
it's
I watered these 3
Wait,
days
9
ago.
volts each?
The whole setup.
Oh, the whole set. Okay.
Yeah.
Oh, you watered them
So-
how long ago?
3 days ago.
Nice. That's really cool. This is a project I can get my head around.
yeah.
Cool, eh?
Very nice.
Absolutely epic. Like real free energy right there.
Yep. That's about as free as it gets. Add a
Yeah,
little
that's pretty
water.
cool.
Very nice.
Hey Ben, what were the stuff you were working on Monday? Sorry, I missed the show, but what was it exactly?
Monday. What were we working on Monday?
You know,
Let's
you sent an
see.
email to everybody.
So that day, I believe we were trying to measure some of the current voltage coming off of the lightning thief to see if we could get an idea of the efficiency. I believe it was that day we also attempted to partially close the loop with the paradox box, but that turned out to be a misreading. I've since corrected that and just I'm not using the paradox box right now. So basically, just what we went over earlier.
Okay. The Pandora's box or the paradox box?
Yeah, either or. Honestly, we can't really market these things as with the names that I have. If we want to like put them in the Coil Kits lab shop, a lot of devices already have like there's already a Lumen lamp and there's already a paradox box, puzzle box, toy or whatever. So, if we want to put them on the Coil Kits lab shop, we're gonna have to change the name of some of these things, but they're pretty
Okay.
easy to build. Like if you want to, it's just 2 magnets glued together. I don't know how Michel did it. I'm gonna have to ask him, and maybe we'll put together a tutorial. But he glued, these 2 magnets together, north poles facing each other, and then just wrapped the bifilar coil around it. So it's very simple.
Okay.
Yeah,
Here.
that fascinates me right there with because it was Boyd Bushman that talked about how you force 2 magnets at the same pole together and you get a little bit of an anti-gravitic effect when dropping them, and then by putting the coils around it, having it in the center, that's a very key aspect to go.
Yeah, that's cool. I haven't even considered that. I'll have to look into it. You said it was Boyd? Boyd who?
Boyd Bushman from Skunkworks before he died.
I'll have to check that out. Yeah, because this is a really cool device that Michelle sent me, and I have barely scratched the surface of what it's capable of. So I'm gonna need your guys' help to try to figure out how to implement this in the best way, for sure. And I appreciate that, Bernie.
Absolutely, Ben. Loves the work.
All right. Oh yeah, we have the lumen lamp here. I put a new battery in it.
The lumen lamp. So what's powering
Yeah.
that bad boy?
So it's got a 12-volt battery in the back. We're still trying to determine the efficiency, but it appears that the MJ L21194 transistor is more efficient. So just keep that in mind if you decide to build one of these things. It is open source on Michelle's bench, which is Michelle's YouTube channel. But I am working on trying to get some of these out to you guys on the team and stock them up on the Coil Kits Lab Shop.
Very nice work.
It looks like some stuff that you stare at and then you become hypnotized and
It's very relaxing. To be honest, this light, it just has a natural oscillation where the string of lights, LEDs inside just blink on and off, and I don't know, it mimics a candle kind of, so I like it.
Ooh, yeah, that's cool. I'm just wondering, hey Mike, if you use the resonance to blow up a building, but but if you use the resonance level, but with less amplitude, you're still gonna feel it, obviously.
Yep.
But that's probably that's probably therapeutic as well, because I know they're able to kill cancer with sound waves.
Yep.
And stuff like that.
Yep. Well, that's
So-
what they're using. That's what they're using on my shoulder right now to break up the calcium that's in my shoulder.
Is it radio frequency?
Oh wow.
Called radio
Yeah.
frequency. Yeah.
Ultrasonic. Yep.
Radio
Ultrasonic,
frequency ablation or something like that.
Well, it just you put a high frequency into it, it starts breaking up, just kind of like the graphene.
Yeah, they're also trying to utilize that kind of ultrasonic technology to break up the gunk that causes dementia inside the brain, which is very cool. Could imagine you not being 100% better, but imagine going out of like one session and being significantly more clear-minded if you're suffering from that ailment. That would be potentially like revolutionary in that realm.
Or like kidney stones,
Yeah, that too.
Yeah.
Those are very painful.
Yeah. It's just cool. It has a lot of benefits. A lot.
So, Mike, real quick, because I did measure the the DC current and the voltage on the lumen lamp to try to get a gauge of the efficiency, and just based on those readings, and Michelle said I have to hook up a 1 ohm resistor just to get the full power. But just based on those readings, it was reading basically it was maintaining the voltage. It was only a very, very slight loss in voltage, like a 0.01 millivolt or something.
Yeah.
And so basically the voltage was being maintained, but the current was 280 going in and 260 milliamps coming out, which is really interesting.
Yeah. So
if we go just based on that, that's around 93% efficient.
Yeah, quarter of an amp.
Yeah. So it's I don't know if that's the full official efficiency, but we're gonna do the 1 ohm resistor test and see if we get some similar results. But I don't know. I have a feeling that this thing is a little bit more efficient with the light bulb that I've attached. So it's just a gut feeling.
Yeah, cool. Yeah, just try what I told you earlier with the capacitor and the full wave bridge.
Yeah, we're gonna do that with the lumen lamp. Hopefully, because the lumen lamp is using the same circuit, but it's using a different coil. So maybe we might be able to get a little bit better results with this.
Yeah. Yeah, when you're working with this high frequency stuff, you have to set the waveform in a way in your configuration in order to get a real good reading on it, because it's very, very hard when you start dabbling with the stuff we're dabbling with.
Yeah, I've noticed that getting a full picture of the power factor of these systems is not straightforward by any means.
And you definitely can't use regular equipment, and most of the digital stuff, you'll lose the type of energy that you're trying to measure in it and all sorts of things, right?
Yeah, for sure.
Can you see my screen?
My bad, we
Let's
double
try.
clicked. Sorry, we double clicked again.
Oh, there we go.
There you go.
What happened?
It's on.
It's up now. We see it.
Oh, yeah. Okay, I just stopped hearing noise. I was wondering, did I get cut off or something? So you want, yeah, you guys want to see something cool?
Yeah, dude. Yeah. Yeah. Bill, you're amazing.
Yeah. Look at that. The station extreme light. It can create 100 petawatts power of laser.
Petawatts. How big is that?
Petawatt.
Petawatts.
That sounds big.
Is that 10 to the 20 something, 20?
Yeah, 10 to 15 actually. It's 100 petawatts, so it's 10 to 1 times 10 to the 17 watts actually. Watts. It's crazy, man. They're able to create that type of laser these days. And they say that it's
That
able
like
to
burn
it's
through space-time, no? Like, that's crazy strong.
I know, it says it's able to cut through time, space time, and things like that.
Oh my god. It's gonna rip a hole through our
Yeah, that was from this week, because this week I did some research on how to produce the way to produce the strongest electric field, and I just figured, well, if we use a powerful laser and we create pair production from that with 100% efficiency, then we could create an extremely strong electric field. But turns out we don't need that much power to create a force field. So that's why I was looking at that much power. But it's pretty amazing where we're at right now. Actually, it's from China, but we got to do something better, man. Hopefully, Canada will come up with a better laser, 1,000 petawatts. How about that, Mike and Bernie?
Anything Canada does that's remotely like best of the world, America instantly shuts down, aka the Arrow program, aka BlackBerry, and I think that's all we ever did.
What about the Maple Leaf generator?
Haven't even heard.
I'm kidding.
Maple syrup generator.
I was about to say the maple. Good thing they haven't taken our maple syrup over yet. It's still hard.
Yeah.
Maple syrup generator.
They don't know the secret yet. That's why.
You know, because you said it now. If Trump is listening, you know, he better watch out. Like, he might.
It's the fuel to start your day. It makes a sweet day out of your pancakes and waffles, right? It's the fuel of the future.
Oh man, you guys keep talking about food. All right, I'm hungry now. I need to.
I know I'm eating.
Right?
Like, stop.
Mike keeps eating too. He's been eating from the start.
Yeah, almost. Not quite, but
Teasing us, Mike. I'm just gonna go grab one thing, and then I'll be back in a couple of minutes and do a quick presentation before it ends, I guess.
all right.
Nice. I'm gonna go grab some poutine fries.
Yeah, me too.
Poutine.
That sounds good.
Poutine.
Yeah.
Yeah.
we're gonna eat a bunch of what's his
Actually,
name?
no,
Putin from Russia.
A poutine train, it comes with gravy and curds, right?
yeah. That's funny. Yeah.
I have a question. NASA keeps on measuring to see the planets and other solar systems as the Goldilocks, planets.
Mhm.
But they, like all these documentaries, but they're missing one key aspect. They're measuring for atmosphere, they're measuring for water, but they're not measuring for salinity. If there's no salinity in the water, I don't care if the planet is in a habitable zone, it's still, we cannot, as human beings, live on it. The water has to be salty for life to, for humans to survive. If the water, the mass body of water is not salty, we won't, like,
Yeah.
and so they don't tell people that. They're like, oh, we found Kepler so and so number and this and that. But dude, if there's no salt in the water,
There could be, a billion planets out there. And if it's just missing that one element that could throw the whole part of the ecosystem off, that would prevent that planet from having life.
exactly. Yeah, like it could have oxygen, it could have an atmosphere, but if that water is not like our water, then like it just, I don't.
You know what? It's one of those mysteries that we don't know until we actually get to the place that has something similar to what we have going on here. I don't think we're just a fluke, right? I don't believe in that.
No.
I think there's something else to it. I heard some other fascinating stuff about the moon, where the guy made a pretty good argument. He's talking about our moon, okay? When our moon goes around our planet, it doesn't spin. It's fixed.
Yeah, it's tidally locked.
Position. All the other moons in the solar system don't do this. All the moons of Jupiter and Saturn, they rotate. They rotate around the body, the large body.
Yeah.
The other thing is, and this is the big one of all, our moon is perfectly round. If you look at some of the moons of Saturn and Jupiter, they're not even close to being perfectly round. Why is it that our moon is the only one in our solar system that is perfectly round?
Well, don't they say it's the mechanical installation put on here as an observation base for some, intelligent life?
Well, the theory he's saying is our moon was not here at the beginning of time. Our moon was brought here.
Brought, or was it stolen by gravity?
No, it was brought here.
Brought. Oh, wow. Okay.
So, and then they started talking about the density of the moon. It turns out David Adair, he's an engineer. And anybody who knows all the David Adair, he's very, very smart guy. And he was coming up with all these points. And he says when they released some of the debris from the Saturn V rockets and it hit the moon, one of them hit the moon so hard, the moon rang like a bell for 3 days.
Wow.
It echoed.
That's hollow. That's what that means.
The moon is hollow, or a great portion of the moon is hollow.
Makes sense.
Okay. He says that moon doesn't belong here. It was brought here. Based on the information that he's got, he says that moon should not be there.
I don't know where I listened to, I'm not sure which astronaut it was, but something about that when they went up there they were kicked off the moon, and there were other species there, and told them never to come back, and only to come back when humans are worthy.
They said they had an ominous presence and they were being watched.
Know why they were pissed off? Why? And David Adair talked about this. He goes, know why they were pissed off? because they're littering the moon. They're leaving all their space junk there. So,
I'd be pissed off too.
right. If you had somebody come, uninvited guest, come over to your house and dump bags of shit on the floor and leave a whole bunch of garbage and then bugger off 2 weeks later, you'd be pretty pissed too.
Yeah.
Yeah.
I've heard all of that and fully agree with everything you said regarding the moon.
I mean, just look at the trash we have circulating the earth. They don't want that shit anywhere near them.
Yep.
Yeah.
Go ahead. You were going to say something?
I was gonna say, like the other day, I was thinking about it, the word alien, and then I made a connection to an Arabic word for it, and it means the same thing. So I wondered, like alien in Arabic, aliyun, aliyun, aliyun means the high above ones.
Right.
Yeah, and
Really?
yep.
Etymology is very important. That might be an important connection, Lulu.
Yeah, and another one, Babel. Bab means door, the Tower of Doors. And if you look at the depiction of the Tower of Babel, it's all little arcs, like little doors. So that was another, connection I made.
I've never heard that. That's awesome.
Yeah,
That's really cool.
Just I thought I'll let you guys know, but the word Bab means door. Babel, Tower of Babel, and how it looks, it's all doors. It's a spiral doors, So yeah, it made like perfect sense of the naming.
I'm just going to scoot out for a quick smoke. I'll be right back. We'll do a little bit of overtime tonight. That's okay with me.
Sounds good, brother. I'm just getting a couple pictures ready.
Yeah, I'll be right back.
I ate before the show.
Yeah, me too. But what can you do?
It's Ramadan, so it's like as soon as the sun sets. But I guess, were you saying you don't practice or do you practice?
I do not. My parents do. I do not.
Right. So I work for like a Lebanese family now in my construction job, and I've learned that Ramadan is, yes, a holy month, but it is also a month filled with hangry Arabs by the end of the day.
I don't talk to my family during the day out of fear. Very true.
Right? Like it's just like up in the morning is good, and then it's like after lunch you just get the death stares because it's like we went out for lunch and they're left hungry, can't even drink water and stuff, and then it's like from that point they're very irritable, very, very irritable. But so would I, it's like you're fasting, so I get it.
They say like last night was the night of destiny. Like your destiny for the whole year is determined by like whatever last night was. Like some kind of, it has to do with the lunar cycle, and supposedly like it writes your whole year's destiny. So hopefully we all had very good thoughts yesterday.
Right? That's fascinating too. And it's like, well, I worked hard yesterday at work, and then I literally got home and slept and passed out. So I guess whatever my dreams were, or working and sleeping, is my year ahead.
Maybe you worked and it's going to pay off this year too. So, I don't know. Think positively.
Exactly. Project the positivity. Jordan, I have not. I just made you a mod in my live chat. If you can post the link to that, I would love to see it. It's interesting. It's on Reddit. Found it on Reddit, he says. More orbs videos. Lulu's got some orbs videos. We got to do an episode just on your orbs one day, Lulu.
I really, really need like help gathering all my devices. I probably have like maybe 10 cell phones throughout the years, like old ones, but they're all filled with fascinating things. Because I never trade in my phone. I keep it because, I don't want them to have what I have on there. It's fine. So I just start up a new phone, but I keep the old one with the information in it. So, yeah.
Right? Oh, I feel that. I've got so many too, and I've slowly started figuring them out and like uploading some of the videos and pictures
Yeah,
to them.
I have to put them all like in one, mega memory bank, and then that way I have easier access to them instead of guessing which phone it's on.
Right? Like it's like uploading them to a external hard drive and then organizing them into different
Yes.
folders for presenting each topics. And
Yeah.
that's what I've kind of started to do and put together a few presentations of.
Man,
And
but
here's
that
one
thing
of them.
looks so gross. That thing looks so gross. Like I don't know. Like,
Right?
is it?
But
It almost looks like a creature in there.
oh, it's alive.
Is
It's
it
double.
not?
It's a double galaxy in a jar, and it's like this is titanium white monoatomics above, and then it's like the reddish orange copper hydroxides as the two counter spinning galaxies below. And there's this aluminum copper electrode that's not plugged into anything, but I just had it in the Ormus, and it separates and creates the two galaxies as you see there. And before I filmed that one I had put more Ormus or the monoatomic stuff into, which disturbed the bottom, which created the dual spirals. And then this one was
Look at
filmed
that.
right before that.
That's
And
pretty.
this
Way.
Yeah, that's neat. It's clearly
Yeah.
got two counter-rotating spirals.
counter rotating, exactly. So this one I had put just a
Wow.
little bit more water in, and it's the water went all the way down, but the Ormus at the bottom didn't spin. It was just the white titanium monoatomics that did the counter rotating dual spiral or galactic spirals on this one.
So what is that?
And you can see the path. I'm sorry, I didn't mean to interrupt you, Lulu.
No. So I'm sorry. Go ahead, Ben.
I was just gonna say, in between the spirals, you can see the path where it's going straight.
Right? Yeah, exactly. Literally, you can see the path where they go straight in the middle, right there. Right? It's
So what is that? Nucleus in there?
Sorry, I missed the part. How do you make them spin?
So I just added a little bit more extra water into the jar, and just the water creates the imbalance that then creates the self-organization spirals.
Oh,
And you
yeah.
can see that there's like this metal electrode there that, and there's two. So this is the, is it loading? Oh, I guess that's the second one. Did load? Yes. All right, yeah. So this one's a little bit, this video is a little bit longer than the first one I just played. It was like a minute afterwards, after that first one that you saw, and you can still see them spinning, counter rotating
Oh my.
as they move further down.
That's cool.
Do they turn from something to something else?
It's like just the entropy of the new water that's put in, or new solution, the new charge. It's the charge of the water that creates this imbalance, and then the spiraling self-organization aspect.
So
you're gonna have a black hole in your jar, dude.
Yeah, you've heard of
Right,
a jar.
exactly.
He's creating a galaxy in a glass.
A jar, right? No, it's a
Yeah,
jar.
a jar,
These are. This is a jar. This is from above. So it's like, yeah, I've got the galaxies in the jar. So this I had added a little bit more water. Of GANs, or the Ormus stuff, that then went to the bottom and stirred up this dual counter-rotating spirals. This was taken probably like an hour after the first two, and then after
Well, you
this,
can see how they're formed. You can see in real time how the galaxies are formed using that motion. So cool.
Oh, absolutely, right? It's
Imagine if
micro to
little
macro.
creatures in there, and then all of a sudden they think we're the gods.
Right, just like the Futurama episode with Edward's like case and stuff.
Like,
For
you know,
sure.
hello there, hello little creature.
Bernie's the god.
Or do you live in there?
Where's the planet Klingon?
Somewhere around this aluminum. I'm not going to say because it's a child's or a family-friendly show. So here's the final video, and this one was taken maybe a day or so later, and you can see that I removed that aluminum copper electrode that was in the middle, and now instead when I added water, it only formed one spiraling galactic action in there, and it's much larger, right? It's almost taking up about 2/3 of the jar. But when it goes to the beginning again, I'm going to pause it and point out a specific anomalies of extreme surface tension, but not just surface tension. So these are bubbles right here, and they're actually a few inches below the top of the water, and that they're held electrically, I guess, charged, suspended in place, and that despite the fact that I had added additional water into the jar, those bubbles remained in this suspended, I guess, electrobuoyant or electrogravitic suspension within, and much below the surface. So it's not even surface tension that can be claimed that's preventing the bubbles from breaking and going up. They're literally being held at the same depth that this spiral is further over in the reaction. And it's like you can see that there's some that comes around and then joins into the spiral, and that on the surface itself, that it's also moving the particles that are floating above the water, even though there's an exclusion zone of several inches between where the spiral is happening. The monatomic Ormus, and then clear water for a couple inches before you get to the surface of the water of the jar, and that it's still mimicking or having that same motion. And the biggest aspect of it is that it's all electric charge and entropy that causes and drives these motions, as opposed to these eddy currents from heat distribution or whatever. It's actually electric charge that dictates the motion and their position.
It reminds me of the Nirvana song "Sappy." You know, they whatever is inside your galaxy, they live in a jar and they think they're happy.
Right?
Yeah. Sorry, I was just getting poetic here.
No, I like it. It's good. And then I'll just finish off with one more video. This was from about 10 years ago, and this is, I had made some silver bismuth monoatomic combination in the base, and then after using up all the bismuth, then I added an additional silver piece, so then it's also silver and silver monatomic, so the mixture of the two. And you can see at the very bottom there's like this giant galactic flow, and then the galaxies in a couple areas, and then you can see above where the galaxy flows of motion of some of the Armus is that there's also clouds moving in opposite directions and specific straight directions, and over top of each other. Like there's several layers of specific motion and direction, but that they're not interfering with one another. They position themselves by charge once again.
Nice.
And then also, I believe you can see on that a couple times I pick up or I, with my finger, move that floating lid cap, bottle cap that is metal, and that it's also it's directly in the center, and it keeps being drawn back specifically to that spot.
Cool.
Quite fascinating. That is like the magnetic center of it.
It's like the Lorentz force, you know.
Well, you can see the magnetic lines of force.
Right? Yeah, like in the actual spiraling motion of the Ormus below.
So what's up with the I'm gonna share my screen one sec. The lines of force, it's an extension of the quantized. Sorry, one sec here.
Sorry, Mike. It was like we click at the same time to start, then we both did click for a minute, and then like clicked again at the same time. It was funny.
Yeah. That's the representation of the quanta here, and at a greater scale is going to create some sort of lines of force if you extend it. I'm just trying to link the lines of force with the quanta or the discrete curves. But anyway, I guess I'm talking to myself. I just don't understand myself here. I'm trying to understand the lines of force. You know, because it's like a quanta. You know, you have a plateau of force, and then after a certain distance, you have another plateau of force. Then you have another plateau. It's just like the quantum forces. You know what I mean?
Yeah,
but it's just at
so
the micro scale.
Exactly. That's exactly what it is, and it's the charge separation, and that you're bang on how it forms and the distance, and then it drops off, and then you got the inverse going the next way, and then these little neutrals, and that it didn't really have pictures or examples ready to show or that we're demonstrating in those videos, but I've got a lot of times in between those counter rotating charge separations, you'll have a what is it, like I forget the exact term, but it is a line of force that is perpendicular to the other two directions, and it will capture and hold all of the matter. It's it'll come to me. It's like a plasma field or something like that. I'll have to look back. It was in the plasma crystal video that I did in stream that I did that Biolumin channel read off a whole bunch of definitions, but specifically. It's this like force field of energy between the two charge differences, and that creates this field of force.
Bernie,
Did
you see that video I showed earlier about the pyramids?
I have not yet. I would
Okay,
love to.
I'm gonna show it again because this will really spark a really good conversation. So I'm gonna show.
Yeah, I forgot to show something also after I'll show it.
Okay.
I actually, guys, I gotta work in the morning, so I'm gonna take off. But I appreciate everything.
Just take a coffee, man.
All right, much love, benefactor.
Yeah, I appreciate everything, guys.
Oh, hold on here. Just bear with me here for a second. I'm gonna pull the channel up again. Just give me a minute here.
Just wanted to thank the chat real quick before I leave. Thank you, chat. You guys have been awesome.
Yeah, thanks, Ben. Okay, here it is. All right, got it. Screen. Okay, check this out, Bernie.
Corrado Malanga from the University of Pisa and Filippo Biondi, involved in radar and remote sensing research with the University of Strathclyde, published peer-reviewed research in 2022 via MDPI entitled Synthetic Aperture Radar Doppler Tomography Reveals Details of Undiscovered High-Resolution Internal Structure of the Great Pyramid of Giza. Their research was conducted using SAR-DAT, synthetic aperture radar, along with proprietary software developed by Filippo Biondi that transforms the radar signals into phononic information, which allows for the detection of millimetric vibrations. This cutting-edge technology is capable of revealing underground structures invisible to traditional methods and revealed internal structures never seen before. Having established their key
that's a massive pyramid
to explore pyramid structures non-invasively, a recent press release on their current project was released last Saturday. This March 15th press release summarized the key findings in the team's research of the second largest pyramid of the Giza Plateau, known as the Khafre Pyramid. And what they found was astonishing. The analysis of dozens of tomographic SAR images obtained from different angles enabled the 3D reconstruction of inside the pyramid of Khafre and deep beneath the surface of the plateau. Near the base of the pyramid, 5 identical structures are seen, connected by geometric pathways. Inside each of these are 5 horizontal levels and a sloping roof. Below these 5 structures are 8 cylindrical structures, which appear to be...
Holy F. If this is legitimate, this is absolutely mind-blowing. And look at those like solenoid freaking like, that's electromagnet essentially. Like you have the winding around, if that's water or ferrite, that's like your bar. And then if that's conductive, that is your solenoid around. So you have a whole bunch of these massive giant electromagnets going ridiculously far below, and then above it those freaking resonator chambers shooting up. Like,
know how deep they go? Know how deep they go? 2 kilometers.
Wow.
Be vertical wells, hollow inside, and surrounded by descending spiral pathways. These 8 vertically aligned cylindrical structures, arranged in 2 parallel rows from north to south, descend to a depth of 648 meters, where they all merge into 2 large cubic structures, measuring approximately 80 meters per side. The entire structure extends approximately 2 kilometers beneath the surface and extends beneath all 3 pyramids of the Giza Plateau complex. Mainstream Egyptology tells us that the Giza pyramids were tombs for pharaohs Khufu, Khafre, and Menkaure, and that they were built around 2500 BC using ramps, sledges, and levers. But the redundant mathematics in their construction, which include pi, the golden ratio, and the speed of light, along with the testimony of today's expert architects, suggests that the official story does not hold up. The massive underground structure revealed by the recent SAR data shows what appears to be a mechanical or functional system.
Yeah, so thick tube, then empty, wrap tube, whatever these massive chamber buildings are, and that it also looks like right at the top of those tube spiral things, before you get into the pyramid, there's like a straight row of what almost look like tuning fork, macro tuning fork things, Ray. Like, there's so much to this. This
is earth shattering.
And like China released like a month ago with like some new satellite plasma system that they did, or whatever, that they found that right above the Giza Plateau pyramids, there's what they call this plasma cloud going into outer space from it. And then on the opposite side of the world, on like some islands that are exactly the opposite side or whatever the heck, that there's like parallel or identical or similar plasma cloud or something, like, which that just what?
Let me finish the video here.
For sure.
And this has been hypothesized in the past. Nikola Tesla believed that the pyramids could harness Earth's natural frequencies. This arguably inspired his experiments in wireless energy transmission and scalar waves. In the Giza power plant, Christopher Dunn argued that the Great Pyramid was a power-generating machine using resonant and acoustic forces to convert mechanical stress into electricity. In the Giza Death Star, Joseph Farrell proposed that the Great Pyramid of Giza was a weapon of mass destruction using a type of physics that he calls paleophysics to focus energy as a scalar weapon. The cylindrical wells could be conduits for energy or sound waves, and the cubic structures might serve as energy storage or stabilization units, akin to components in a large-scale weapon or generator. And the detection of vibrations in the pyramid's internal structures reflects all of these ideas. The Khafre project hopes to plan an excavation in order to discover more about this underground structure, but history shows that this will be very difficult to get approval for. Greg Reese reporting.
Okay, can you play the beginning 30 seconds again, please, Mike, where it gives like all the details of where this report came from, and it explained the technology quite well, which...
Corrado Malanga from the University of Pisa and Filippo Biondi, involved in radar and remote sensing research with the University of Strathclyde, published peer-reviewed research in 2022 via MDPI entitled Synthetic Aperture Radar Doppler Tomography Reveals Details of Undiscovered High-Resolution Internal Structure of the Great Pyramid of Giza. Their research was conducted using SAR data, synthetic aperture.
That race of the two and 2022, they claim. So I'm gonna have to fact check that afterwards and look in, but that sounded pretty legit. Like, that's...
I'll put the link for the video in the private chat.
Yes, please.
Can you guys imagine what they could do with this technology? Like, I mean, we could like uncover everything. I mean, everything. Like, if they could peer,
Right.
like 2 kilometers, beneath the ground, like everything that has ever been documented and lost could be refound. Right?
Exactly. Like, we're reaching this point where everything is now being seen or about to be seen and found.
What it's showing us too, what we suspected all along is true.
Yeah.
The Egyptians, the guy who is, I guess you could say, the gatekeeper for the
Howie Ross or whatever the heck his name, beyond gatekeeper. Horrible dude.
So and he's hiding this. So Now they're using this advanced radar system to detect structures below the pyramids that a lot of people suspected for a long time. So Warden Cliff Tower was based on the pyramids. Tesla knew there were structures below the pyramid. Why do you think Tesla built the Tesla coil the way he did? Because he knew he could send power through the air as well as through the ground.
But you notice something? They supposedly they use this as a defense system. Defense against what though? Back then, there was no, like known Air Force or any like anything that another country's gonna come through the
Maybe
air.
there was an Air Force. We just don't. There's a lot of hieroglyphs and models, especially in India, of flying machines. So
it's interesting, right?
Right.
Like, yeah,
Good
what are
call.
they protecting?
All the Vihamas.
The Vimanas. Yep.
Another thing that could come to mind: what if they directed it towards asteroids or meteorites or things like that, and that was
Nobody realizes. It would be so cool if that thing was still active, like from the original design of it, if it was still active.
Yo, right? Compared to like it, obviously it's still got some functionality if there's still this plasma cloud that was just detected by the Chinese, but compared to like when it had the white casing stones, the actual capstone, whatever was working on the insides, like it would have been probably shooting like whatever. What was that laser you were talking about earlier? And like what
the station of extreme light.
Hey.
But the measurement, it was like 25, like something to the power of 25 laser. Like that's what I would see coming out of those things if they were actually still functioning.
Petawatt.
Yeah,
petawatt, right? Like petawatt Caesar, maybe.
Well, don't forget too. Tesla came out with the Teleforce weapon. Maybe this is where he got the idea of the Teleforce weapon based on the pyramid design.
Very
so not
true.
only that, it was also a directed energy weapon as well.
I would think he derived that on his own. Like he was like so smart to the point where I think he conceptualized that.
He channeled a lot of stuff. Like it came to him in dreams, and that like he'd then work on it in his mind and stuff. I believe.
I mean, maybe, yeah.
Yeah, he came up with it in his head, and
didn't he say that he was in contact with the aliens at some point?
Yeah, he said he did have. I guess you could say like a download.
Yeah.
He used to.
I believe it.
You know what?
I believe
there's some folklore out there that when Tesla went to bed every night, he left a pad of paper beside his bed, and in the morning there would be a complex electrical circuit drawn or invention on that pad.
I believe that.
Now
I'm gonna have to start trying that myself, right?
Was it his handwriting or was it somebody else's handwriting?
Exactly. That's the folklore. Exactly.
Okay, but truly, I do believe in the whole download because it does happen to me often. Like I would have no idea.
Even
about
Tesla said that too. Tesla said that too.
And I would wake up and I would know things that I know I didn't read, I know I didn't see, and I know I didn't come up with anywhere. But all of a sudden, I just know it.
Yeah. Well, Tesla said himself. He says, I didn't come up with this knowledge. This knowledge was given to me from out there. And at nighttime, this is when he got these downloads. And then mysteriously in the morning on the pad of paper, he had these complex engineering drawings and circuits and all the great inventions, the electric motors, all that stuff. this
Can
drive.
I wonder if I could give it parts and it will build something, not just paper. If I could like, give it like parts and sleep and then wake up and then it's all made, that would be cool.
Yeah, I just wanted to add something before the show ends.
Yep.
I completely forgot about it, but it's pretty amazing. So you remember my simulator that I've been working on for on and off?
Yeah.
So I simulated an atom actually, and you can see it uses the quanta as well, the quanta of the energy level of each orbit and all that stuff. But I need to modify by the way, finite theory integrates time dilation in it. That's why it's more stable than its Newtonian counterpart. But if I use the formulas that are mainstream, it doesn't work. I have the exact masses. But if I use the if I use the speed that the textbooks are saying, then it doesn't work. That the orbit is not going to be stable. So I need to modify the speed. The speed is not. I need to divide it by 10 actually, and inverse the energy level because the equation is kind of x so some number divided by the energy level, but I need to multiply the energy level to get the tangential speed. I cannot divide it. So it's everything is in the link. I shared the link. Maybe you can post it on the chat, the YouTube link. Because I'm explaining the equations that is problematic, and that's kind of because it doesn't make any sense. Because Lulu asked me the question the other day about whether the electron has more energy on the greater it gets to a greater orbit it gets or energy level it gets. Apparently, yes, it gains energy, but it's not the kinetic energy; it's the potential energy. But potential energy is not an energy that is within the electron. It's just a potential energy. It's not there yet. You know what I mean? So the mainstream equations for the atomic the electron orbits is very messed up, and I want to point that out here also. So I know it's hard to digest what I'm saying in 2 or 3 minutes, but it's
Well, we got to do a full episode covering that, Phil, because I'd like to get you to enter a few different chemical atomic simulations into what you're doing there, because well, it's a bit of a project, but I love what you're doing, and I want your help taking it to the next level with some of my own predictions and I guess the cold fusion sort of thing, but that I would like to run some simulations with different isotopes and whatnot.
That's the goal to predict nuclear fission and fusion and all that stuff, and chemical reactions also.
Exactly. Bang on in what we can do together with that. Some serious work.
Yeah, definitely. I got the electric forces. I still need to integrate the magnetic forces because the electric field, the electrons are rotating and it generates and it induces a magnetic field as well. I just need to integrate that and then I'll be good because I've got everything else running fine. And it uses the same generic equation to explain the black holes. So from the atomic level to the black holes, I'm using the exact same equation.
If you can stabilize those the orbits, the electron orbits, man, you probably should win a Nobel Prize. You don't understand. If you integrate
Right.
the magnetic field into the equation and have it as the state a stable electron orbitals, like
Yeah,
just probably, I believe you really are onto something nobody has yet reached in really analyzing how the orbits and the electrons move.
yeah, definitely. That's. I mean, again, I'm gonna show you since you. I'm gonna. Sorry to doubly extend this, but I want to show Bernie since he's here. The
Absolutely. Pull it up.
the quantum the quantum. Sorry, somebody's presenting something here.
Just the
Uh,
video I got playing in the background. Don't worry about it.
oh yeah.
Pull up.
So the simulator is able to simulate the quarks as well. So it's really acting like a quark. Can you see my screen?
Yeah.
Yes, sir.
Yeah.
Yes.
So
Yeah.
it simulates the quarks as well. So it goes down to the quantum level as well. So yeah. So it goes. I'm using the same equations for the quarks, the atomic level, and the
Perfect. The
black hole.
micro to macro full scale. And that, have you read the recent unified theories with using entropy as like the missing aspect of connecting electromagnetics and gravity?
Nah, I heard about it, but I didn't really look in depth on it. But I
There's a
heard
few.
about it.
Yeah, I would recommend it because that's what got me onto this um, kick of it all, and that then I was on like a week long, right, like channeling some science stuff, like some source code sort of thing, and then like trying to make sense of it and put it all together. Had a lot of private chats, private science streams with a few people and stuff. But one of the main things that I came to the conclusion of was that I need to work with you, Phil, on specifically rendering these isotope things with in regards to it's the electromagnetic charge of uh, the position of the electrons in the rings forming the bonds and the breakdown of them from the charge, and doing that modeling and the isotopes that come out of it that would be able to, well, the results will be, it's what I'm missing to write my paper, I guess my full thesis on the um, electrochemistry, fusion, fission, and process sort of thing. Anywho, that was
Okay,
a bit
cool.
of a off tangent and stuff. What we're looking at right now here is a triple copper solenoid that is nano coated on the left side, and you can see a bunch of bubbles starting to form on it. And then on the right side is from the top is just a single copper wire that's nano coated that goes down into the jar and connects to another one of these little copper nano coated solenoids. There's no electrical charge going in, there's no outside charge going in, but you can see these lines of monoatomics and flow going from the wire to the solenoid, and that this jar had been sealed for a couple of years. I opened it up, and then these flow, it literally like comes to life with like this self-organizing flow of material from one to the other, as it creates a little, I guess it forms one as an anode, one as a cathode, and uses them as electrodes within the self-organizing electric charge, the charge differential, and what it does, how it does that. But yeah.
So you have a potential of energy here.
Exactly. It creates a large potential that runs, and once it gets going, it will run for like a solid 3 months to a year, depending on the setup now, and it'll produce hydrogen nonstop on its own. And that when I measure, there is a bit of a voltage from the differentials of where I place them and how I structure the triple solenoids, which also
that's the electrolysis device that you were talking about.
Yeah, one of my like saltwater electrolysis devices that I've made myself. But yeah, this one has zero electrical input going in at all. It's just from the positioning of the coils and the nano coating. But
Nice.
all that is in that solution is salt water and copper, and it had been sealed for a couple years. I open it up and the reaction starts and it goes.
Nice. That's pretty cool.
Yeah. Figured I'd just show that while I had it up. Anyone else, any last things to say? I'm guessing Mike, you're getting ready to shut her down in almost 3 hours there.
Yeah, it's pushing midnight here. Been a long day.
Yeah.
No
I
doubt.
gotta try to wake up and train tomorrow morning. Try to. I'm not sure.
Well, guys,
try.
Thanks a lot, everybody, for tuning in. Chat, you were great. Awesome chat tonight. Some really good conversations going on.
I got one question.
Yeah.
Anybody in the group or in the chat has a rubidium atomic clock?
If you have an extra, first send one to Phil, then send one to me, then send one to Mike. And yeah.
Yeah. Cool. All right. Thanks.
Yeah. So, we go live to air again next Friday night. Tuesday is Mr. Faraday's birthday here. And,
happy birthday.
Happy birthday.
Well, happy birthday, brother.
Thank you. Thank you. A lot of birthdays in March. My cousins and my brother's son. He's on the 27th. I'm on the 25th. My wife is March 2nd.
You're a whole March family.
I know, except for my daughter. My daughter is in April, but everybody else.
Close.
Yeah. All right, guys. Have a great night. Thanks a lot, chat. You're great. We'll see everybody next week.
Awesome.
Take care. Take care. Thanks, guys.